This video will show how to draw cyclohexane rings and how to put the substituents in the right positions. So first we're going to practice drawing cyclohexane in the chair conformation with all of the axial and equatorial positions filled with hydrogens. Start with the axial positions because they're easier to draw. There's 6 axial positions and all of the lines are going to be vertical. So you can see as the first 2 go in that at carbon 1 the axial position is straight up and down and it's going up out of the carbon, and then at carbon 2 it's still straight up and down but now it's going down, and you'll notice that it oscillates back and forth. It'll go up and then down and then up at the next position and then down at the next position, and then it goes up, down, up, down, up, down. So there's 3 up positions and 3 down positions for the 6 axial positions in one cyclohexane ring. So now we're going to draw the 6 equatorial positions. They are harder to draw. One hint is that you can use pairs of parallel lines to help you draw the equatorial positions. So first draw the ring, and then in the first position, I've done these in green. In the first carbon, the equatorial position is going down, and then at the next carbon, it will be going up. So that back and forth between down and up is still the same for the equatorial positions as the axial. And then the next one's going down, and then the next one will be going up. It'll go up, and then down, and then up. So again, there are 3 down positions and 3 up positions. So now we're going to draw, I want you to practice the chair conformations. First, drawing the 6 axial positions. Practice this until you can do it pretty easily. And I've done one just as a sample, but you should be able to do it at least 3 or 4 times. Okay, and again, practice drawing the chair conformation with the 6 equatorial positions. Repeat until you can do it without looking at the instructions, and again, this one takes quite a bit longer. You might want to use scrap paper. Definitely stop the video and practice on your own until you feel really good about it and you're comfortable drawing. So now practice drawing one chair conformation with all 12 axial and equatorial positions, 6 axial and 6 equatorial for 12 positions. Repeat until you can do it without the instructions and pretty comfortably on your own. Stop the video and practice. So just to get you started, I have done, again, just like before, the axial positions in blue and the equatorial in green. So notice that every carbon has 1 axial, 1 equatorial. If the axial is going up, then the equatorial is going down. And that holds true as we go around. So at carbon 2, the axial position goes down and the equatorial position goes up. And it keeps going back and forth around the ring. Axial goes up, equatorial goes down, and then so on. Now the axial will go down at carbon 4. And then the axial will go up and equatorial will go down at carbon 5. And again, it goes back and forth. So practice this until you're pretty comfortable at doing all the positions. So for practice, this compound is a bicyclic compound. So it's 2 rings fused together, 2 6-membered rings fused together right here. It has a couple of methyl groups fused, attached. So, and the hydrogens are not drawn. So what I want you to do is to go through and draw all the hydrogen positions and identify the number of hydrogen atoms that are axial and the number that are equatorial, and label them and count them. So stop the video and try to do it on your own, and then turn it back on, and I'll show you the answer. So what I've done is, again, done the axial positions in blue, and I haven't drawn the H's just for space, and then the equatorial positions in green. Notice that the ones in the back are a little bit hard to draw, like that's one carbon right here, and the axial position coming down. But to show that it's in the back of the molecule, then it's sort of chopped up like this. But that's one bond here, just like this one is one bond here. So if you count them, you count 8 axial hydrogens and 7 equatorial hydrogens. Keep in mind that each carbon can only make 4 bonds. So a carbon such as this one already has 4 bonds and doesn't have any hydrogens attached, so it doesn't have any neither axial or equatorial hydrogens. A CH2 is going to have 2 hydrogens, 1 axial and 1 equatorial. And then a carbon like this one here already has 3 bonds and is only going to have 1 hydrogen, because this bond here is already equatorial. If we're looking at this ring, then the hydrogen has to be axial. So this is probably the trickiest bond in this, the trickiest hydrogen to figure out in this situation. Okay, so now we're going to talk about if a ring contains a substituent, we call it monosubstituted, it has one substituent on the ring, then 2 possible chair conformations can be drawn. One of them has, I've drawn a chlorine at the 1 carbon. I could draw the chlorine going up in the axial position here, and if it is, then the hydrogen would be going down in the equatorial position. If I take my ring and I ring flip it, then this right here is carbon 1. It still has a chlorine attached, and the chlorine is still in the up position, but now it's equatorial. And the hydrogen that's attached is still in the down position, but now it's axial. So substituents always in a ring flip go from equatorial to axial or axial to equatorial. So this ring flipping can be pretty difficult to draw. I'm going to practice pretty much for the rest of this video. Draw both chair conformations for bromocyclohexane, so it's a cyclohexane ring monosubstituted with a single bromine, but I want you to draw all the hydrogens also for practice and show that they're all going to ring flip. So stop the video and then do the drawing and then turn it back on to check your work. So at first we draw the ring in the chair conformation and draw a bromine in the axial position. I could have picked either position to start with. I picked the axial to start for the bromine, and the hydrogen is equatorial. And then I filled in the rest of the hydrogens exactly like the rings that we drew earlier. But now the ring is going to flip, so this carbon here, which has the bromine attached, is going to go down, and this carbon 4 at the other end is going to go up. So when carbon 1 goes down, it goes, this carbon here is this carbon in the ring flip. Again, the bromine is still up, but it went from axial to equatorial. And the hydrogen is still down, but it went from equatorial to axial. Again, filling in all the hydrogens. And then what I've done, what I'm going to do here is show you that all of the hydrogens that were equatorial are going to flip to the axial position. So to show that, I've going to circle them in a color. So the bromine went from axial to equatorial, and so did all of the axial hydrogens. So here are the axial hydrogens. Notice there are 5 of them because the bromine takes up the 6th axial position. And when they flip, all of the axial positions are now equatorial. So again, they're circled in blue, and you can see that, so the circled hydrogens are the same. So this hydrogen here is this hydrogen here. Again, if it starts out in the down position, it stays in the down position, but it goes from axial to equatorial. So that's what's happening with the blue. And then with green, I've circled the equatorial hydrogens on the left, and then flip them. When the ring flips, the green hydrogens are still the green hydrogens on the right, but they've gone from equatorial to axial. And models will really help you to see this. So for practice, draw both chair conformations of the following 3 compounds, and they're shown on your paper. Stop the video and do the drawing, and then turn it back on to check your work. So the hydroxyl group, which I've put at carbon 1, starts out in the equatorial position, and it's going down. And then after the ring flip, it's still going down, but now it's in the axial position. For the next 2, I've tried to move the substituents around the ring a little bit so they're not always on the same carbon. Okay, you'll see I made a mistake at that methyl and I fixed it. So you can see that the nitrogen, the NH2 group, goes from equatorial to axial, but I've placed it on the same carbon after the ring flip. And then the methyl group goes from, again, equatorial, and then it flips to the axial position in the ring flip.